These are the 3 telescopes at the Kennedy Space Center being lifted. Again, impartial. I think it's a beautiful payload. It's unique. Shuttle has flown a lot of cool things, but the challenges for asteroid, not independent of the optical aspect and the pointing aspect and the thermal aspect, but getting this thing put together and co-aligned. For instance, when we were up at the presentation, there was one of the engineers who talked about the alignment challenges, even in the operations and checkout building here. The daytime and nighttime measurements were different because the building warmed up, and even though this is like 3 feet of concrete, it would change just enough that arc-second precision stuff was affected. So they had to do something on the same time each day and then compensate for the mathematical model. This was testing of the instruments at the Kennedy Space Center, and I know this is hard to believe. That's you. That's me with the hair here. That was a long time ago. That's the Whoopi team right there. This is 4 astronauts. Anyone recognize this guy, young guy? That's Jeff Hockenbaugh. This is Sam Durrance, Ron Parise, and the backup payload specialist, Ken Nordsick. This is the person I replaced on Astro 2. Ken chose not to fly, which was surprising. He would have got a flight seat. He is the consummate scientist. He said, "No, I spent too much time training on that flyboy stuff. I don't want to do it." Okay, I'll do it. Ron and Sam, yeah, we'll be happy to fly again. So they had 2 flights. Ken stood down, I filled in for him, and Jeff Hoffman flew many, many missions. I know some of you know him. He's a great guy. This is the Astro 2 Astro 1 before we met BBXRT. And forget the circles, at the time we were highlighting some people. But again, a very pretty payload and complex. And this picture probably would have been taken within a few weeks of the Challenger. So we were all dressed up, ready to go. That was the payload. And again, actually, the OPF, Orbiter Processing Facility. We were pulling out the dust covers. And mentioned Challenger. So we had a bit of a gap there. So let me talk about some of the highlights. Because of Challenger, the original mission never flew. It's going to be STS-61E. And it had a crew that never flew. Ron and Sam Durrance, the payload specialist, of course, went on to fly Astro 1 and Astro 2, as well as Jeff Hoffman and Bob Parker. But the pilots and the other NS did not, because it was just this 4-year gap from 86 to 90. And here's a little fun fact that probably very few people know, except maybe Mark, because he was at my presentation with Bert. I went into a standby mode. And in standby mode, you have to kind of, check and do regular maintenance on the payload. One of the things we did was to exercise the gimbals of that pointing system. Well, when they exercise the gimbals on the payload system, it's not easy to do. Like I said, it couldn't lift itself in 1G. You have to put on a bunch of counterbalances. When they hooked that up and started driving it, it couldn't come out of what the storage bumper ring. There's this ring that protects it from hitting the sides of the shuttle, but it couldn't correct itself out of it. Let me pause there. That says, had we flown in 86, we would have gone on orbit, the crew would have activated and tried to start erecting this telescope observatory. It would not have come out of the launch bumper ring position. So if there's a silver lining with the delay of the Challenger, it's to save this mission. And you wondered, how could that possibly happen? I don't want to pick on any safety people if they are here, but late in the flow, some analysis in a safety group says we need to tighten up that envelope for protecting this thing from hitting the side of the shuttle from 6 inches to 8 inches. And so they remilled this bumper ring and said, you need to put that in. And our mechanical group, I'm an electrical guy, but our counterpart said, no, it's all been tested, good. No, we analyzed it. need to change it out, it's a safety issue. They changed it, and that's what happens. Test is best, right? Oh, there it is. I have a picture for you. This is that bumper right there. So this is the gimbal system, and if you can use your imagination, this circle tilts up and out of there. So this ring right here has to clear that and that. You can see it looks really tight, and it is. Well, it was too tight for Astro 1. There was also some bolt questions that came up and cable splices, so that year gap, or 3-year gap, really saved the mission. So, it's back, Astro, our dog, came back, and we did some things to improve the telescope. Some optics were done, better detectors came along, technology moves on, and Astro 1 flew 3.7 miles, 7 miles, million miles. It was off to a great start, and then this happened. The loss of the data display units, the computers used by the crew, that 64K computer and the interface, first one, then both failed. You never want to hear the words, there's smoke in the cabin in NASA, I mean that sincerely, but there was smoke in the cabin that occurred on that mission. And because of that, they shut those down. The crew no longer had control capability. Well, all of our sims, all of our training was for the loss of one, never two. Within 24 hours, it's its own separate story. The Johnson Space Center, the Payload Operations Command Center at the Marshall Space Flight Center, the PI teams, the science teams, figured out a way to call up and manually acquire. The crew had a joystick to fly too close to where the target is. We could see on the ground where the stars were, up one, left, right. It's like a remote control joystick. And then the scientists send this filter, send this aperture, and the orchestration, and we saved the mission. Within 24 hours, we had a new way of operating. This is the Astro 1 crew. All good people there. Little fun fact there, STS-35 holds the record for the longest land miles of a payload flown, or I should say rode on the crawler, and OPF-1, the 83, Patty, for those of you around back then, this was the infamous hydrogen leak that was going on in the orbiter in the 90s, that they would roll out fuel, leak, roll out, leak, roll out, leak, roll out, leak. So that was Rastro, the Draw, the robot dog. Where are we going now? SCS, always ready to roll. But eventually, they took care of those hydrogen leaks on the 7-inch connect lines. Let's see. Managed to go back to this. Oh, I think we're locked up here, Bert. Oh, I think it's a Windows thing. Let me try and close this. So, did you take care of that? Okay. There's that phone number here. Okay, and then this is that. That did it. So, I mentioned a lot of launch delays. We were going to originally launch in 83, 85, blah, blah, blah. That's an actual shirt, and that model said it all. If you remember the song back then, Hopefully Be Happy. Finally, we launched and got on orbit and did good science until this is the computer that went down, the two of them. And we're going to go on to Astro 2 now to move things along. I'm going to skip by this, but it takes a team, and this is true. The coordination, as if it isn't hard enough technically, operating these instruments in parallel and not stepping on each other's toes from a science perspective. This is what failed right here. And because of those problems, the payload, this is the ground team at the Marshall Park, called up to the crew. There's Sam Durance with that hand controller being told where to be positioning the telescopes. But we still estimated that we got about 70% of our data achieved. This is how we replan things, and that is that checklist. I told you within 24 hours, this is how we went. So instead of a computer doing it all manually, and the crew doing commands on orbit, this was our checklist for every observation of every orbit for every day.
Scott, I understand that was the first time that a crew was talked to from not at Houston.
This is a true statement. Yes, absolutely right. The
Great
prior
protocol.
to Astro One mission, the payload operations was all done under the Mission Control Center at JSC. When Marshall got the go to have a payload operations command center, Astro One was the first time. And as if it wasn't already kind of this kind of nervousness by the flight directors at JSC, here the computers go down and they absolutely have to trust that the Marshall Pod and the scientists can do all that mentioned. And that's a nice segue, Mark, because, oops, sorry, let me go back here. This letter right here says it all. You can read it for yourselves, but notice who it's signed by. Gene Kranz wrote a letter post-mission that said, basically, you redefine the very concept of mission operations. This is coming from the center and the king of flight ops, telling Marshall and the astro science community, you did a hell of a job, because the mission would have been completely lost. And 20,000 individual commands went up from the Marshall Space Science Center, 20,000, in which previously maybe 100 were allowed pre-planned. They just basically said, we trust you, Marshall, and that happened.
Do it.
Yeah, it's a great story, achievement story. Astro 2 went super smooth. You learn from that. By the way, they replaced those computers that were there with laptops. That was kind of that evolution of capabilities. You see a summary of the science. This is the crew. Great crew. Of course, this is the crew I trained with for about a year and a half. All personal friends of mine. There's yours truly. Yeah, they put me in for a token picture. And it's funny, and I kid you not, when I arrived here today, this gentleman from India came up and reintroduced himself to me that apparently 15 years ago, I had lunch with him. And I kind of came back to me, and then he pulled out this picture. I go, I don't even have a sequence. So the point being is there's collectors out there, and they like signatures, and apparently us alternates are a rare breed, so I'll take that for what it's worth. Successful mission, some pretty pictures on orbit. It's mind-boggling. I will say one thing. What did they learn on Astro 1 that they implemented on Astro 2? No matter how much you plan, things change. And if you launch 1 minute late, let alone an hour late or a day late, your whole target plan of acquisitions and angles, it changes. So don't fight it. Build a system, real time, that you can send up the data. Well, what you're looking at is the super Rolodex of daily, we send up on a teleprinter, meters and meters of updates. They cut it into pages, put it in a Rolodex, and implement it from that. Lesson learned. Don't try to predict it. Have a good tool system and a methodology to do that. Very successful. It's a pretty table. These are space telescopes looking at the UV, discovering the wonders of the universe, and all of this hardware comes back. It's a busy chart, but every one of these little dots tells you different scientific investigations. At the reunion that was up there, these scientists briefed that, and if you're a nerd into this, I'm not going to surprise you in saying that every discovery is a new discovery, but when they tell you how it links to the things that led to the instrument updates on Hubble, let alone what's on the web and the other great observatories, you realize that the Astro Observatory was this middle ground from, we can do sounding rockets that give you a few minutes of above the Earth's atmosphere. You can deploy satellites but never get them back. That the shuttle now has this capability to do multiple flights, and that's one of its legacies. This is that effect I told you about here, about the intergalactic media observations, where you have a candle here, and you're looking through it back into time and through the interstellar media. And this is all the science kind of geek that tells you that this ratio, there it is, Davidson-Criss effect. It was a big deal. I thought, in fact, some thought it might be a Nobel Prize. I don't have, well, let me tell you a really fun story. We'll just lighten the humor here. I'm a ham radio guy, and if there's any other amateur radio people out there, Ron Parise was a huge radio guy, and there was a shuttle amateur radio experiment called CEREX. So meaning, ham radio is on the space station. When we were operating during Astro 2, there would be occasional periods called LOS, loss of signal. The reason being is the shuttle went around the Earth, there were gaps in the communications where you would drop out for about 5, 6, 7 minutes, depending on things. Frankly, that was the time when the crew got a break from us on the ground, and we on the ground got a break to run it back. That's kind of how it worked. And we were coming up on an LOS, and I was getting ready to make a call to Ron to say, you know, basically, this was going to happen. And one ear is always with the crew, the other ear is with all of the scientists and ground team members. That's how it works. And I was like a CAPCOM, but as it was called, I was in the APS position. This gentleman calls up, another ham radio guy, says, Scott, can you tell Ron that they're coming up over Huntsville, Alabama, and to get on ham radio? We'll talk to them. We got Marshall Space Flight Center Amateur Radio Club is standing by if he calls down. And I go, I can't call on air to ground and say get on a ham radio. You couldn't at the time. That was considered a secondary payload and never you could use it over. So I'm glad I didn't have more than a few seconds to think because I never would have done it. And so I said, Astro Huntsville for Ron, before we go over the hill on Tigris West, we're going to need an item 4 SIR enter. Now, that sounds like a lot of gibberish. We send commands to those computers called item entries, and there's a bunch of them. There's no item 4 SIR, but his call sign is W4 SIR. And so he puts 2 and 2. Copy, Scott. We'll put that in work. So here's where this plays out. He goes down into the mid-deck, grabs the ham radio, activates it. Everybody in the pod, well, first of all, the lead operations controller looks at me. There's no item 4 SIR. I know, don't worry about it. And it kind of bothered her at this time. They all run off and get their break. Sure enough, he calls down the Marshall Space Flight Center, contacts the ham club. There's a phone patch. You know, again, this is 95. There's no cell phones or something. He ties it in, and somehow he gets it into the comm loop, and he gets it into my ear on my headset.
Oh my God.
So I was talking on an official, you know, Tigris satellite 60 seconds earlier, you know, how many hundreds of millions of dollars of comm system. And now in this ear, I'm talking over $1,000 ham radio set, and it's the same. And I can chat now unofficial because we're on the Tigris system. You know, I can say, how's it going, Ron? Yes. How's it going to the ground? You know, it's all polite. You can't keep it secret because it's still ham radio. Here's the kicker. I know I only had a few seconds left. Every observation that comes around, we would call up with kind of last minute cheat sheet stuff, like filter 6, aperture 8, things the crew would never ever know because the scientists have determined that's based on what they see. So, Ron, before you go, I've got some numbers for you. And so I gave him this secret list of numbers. He knew where this was going. So we said our goodbyes. People trickle back in. Everybody sits down, and then I get the call that we're back on Tigris East. Astro Huntsville for Ron, we're on Tigris East. When you have a minute, we're ready to give you the next target list updates when you're ready to copy. Scott, you know, I was just looking at that, thinking we probably need aperture 4, filter 6, and you could see these prairie dog heads coming up over their console. How does Ron know that? And I think my joke at the time was, well, you give the crew a few minutes to think without us bothering them. It really bothered some people that they kept coming up to me. That there's no human way to do that. So anyway, Ron's no longer sadly with us, but I told the story at a celebration of life, and I kid you not, there was probably a dozen people in that audience. That's how they did it. You know, it didn't bother them for another 10 years that there was some secret path. So there's a little distraction.
That's great.
So I'm going to segue now into, let me close this, into after those missions. Here we go, and I think I just do this. And see here, and there. Yes. So at the end of '95, Astro's over. For a short time, there was an Astro 3. Now I'm a little partial to Astro 3 because if had it happen, I could fly. But there was a change in things, if I can be so bold, there was actually a political change. Barbara Mikulski, I don't know if any of you know that name, she's legendary in space science, in support. Senator from Maryland, and she was the the chair of the science appropriations. Change in administration, change in politics, she lost that position, the new chair came in, whatever she supported, they didn't support. So Astro 3, well, Maryland had 2 of the 3 telescopes, and so that sadly went away. Things happen. Space Lab end, shuttle end. All good things come to an end. This hardware gets dispositioned. Well, the Astro Restoration Project, the reason it came along, oops, your battery is running low. Oh, you might want to take a look at that there. Let's see here. This happened yesterday too. And now, I'm sure it's plugged in. Well, I'm surprised I can't advance here. Let me try this, okay? Does that one work? No. There we go.
Let's hope we get it done.
It's not gonna be good. Oh, this speeds me up. I know this is like the hook.
Yeah.
As they dispositioned the hardware, the telescopes from Astro went back to their respective organizations. Whoopi went back to Wisconsin, Hutt went back to Johns Hopkins, UIT went to Goddard. But the rest, all of the other Space Lab hardware, with a few exceptions, got surplus, government surplus. And some of us who worked that seemed wrong. And so we would go to the auction blocks and we would buy this hardware to preserve it, thinking someday this will end up in museums. And it was tough. It was very hard to see that probably, hundreds of millions of dollars were spent on stuff that was being sold for scrap aluminum value. And so we formed the Astro Restoration Project to go in and start procuring this through legal mechanisms, some directly from the auction block, some from junk dealers who already purchased the stuff, and save it and gather people to say someday, particularly when we retire, let's try to put some of this stuff back together, and specifically Astro. And that's hence the Astro Restoration Project. So at the end of '95, Astro flies last Lewis mission. At '98, we start getting this hardware. And I'll use an example. Those 3 telescopes that mounted on this structure to that 1 arc second structure, which is a 3,000-pound orthogrid custom machine structure. A friend called me and said, it's in Arab, Alabama, just been sold for scrap metal. You need to go grab it. I happen to be TDY. I drove out to this junk dealer. That's me right there. And I guess that's the guy. And I said, I want to save this. And he says, well, give me aluminum cash value for it. And it was $1,500. We saved it for $1,500. But had I not cut that call, within days or weeks, all of that would have been melted down. And that's one of many examples of us going and saving this hardware. And then the Astro Restoration Project was formed. So we collected actually before, many years, we formed the nonprofit. And then we partnered with the U.S. Space and Rocket Center to do a living exhibit. We are literally at the museum putting this hardware back together. 10 years ago, at the previous anniversary, is when we first pitched this to the Smithsonian as a project. Valerie Neal, I don't know if any of you know that name, she was the curator at the time. We said, look, you have 2 of the 3 telescopes by then. UIT had been donated to the Smithsonian. We knew Whoopi was still in Wisconsin. We said, we have about 90% of the rest. Let's get the band back together. Would you be interested? She said, of course, it's a no-brainer. Let's reunite the telescopes. And so that's how this got formed. And let me just show you a couple other fun pictures here. This is kind of part of the procurement phase. So this is that instrument pointing system. That's the base it sits on. And there's 2 of them that were made. One for Astro, and that's this one. And there's another one that was used on Space Lab 2, which was a solar mission. That's my coffee table in my house.
Oh my God.
And I tried to give it to Dornier. I mean this sincerely. They have a Space Lab museum, and I gave them a lot of hardware. And I said, you want this base for your IPS? They said, we just made one, and we put the IPS, and it costs too much money to de-integrate and reintegrate. Okay, now it's my coffee table. I put a piece of glass on it.
Very cool.
This is that cruciform. This is the structure that held everything to within an arcsecond. And look how nasty that was by the time we saved it. And there it is in its crate, right there. So phase 1 of our project is, let's save and restore the cruciform. So we rolled it into a facility at the U.S. Space and Rocket Center up in Huntsville, Alabama. And over the course of about 6 months, we took it. I mean, this is pretty nasty. You see the stains. All this multi-layer insulation was frazzling. The cables were nasty. We had to strip that off. And there was a surprise when we did that. There were thousands and thousands of mudhopper nests. If you know anything about mudhopper, it's like little concrete.
Yeah.
It's not like you just flick it off. You have to chisel that stuff off.
Yeah.
Down here is a dead rat. We had bird nests, and all of these blankets had this mildew. It was really, really nasty. So it was a labor of love to strip the blankets off and clean them. Each individual blanket took weeks and precision attention. The chemical that we ended up using, based on the recommendation of the Smithsonian, you have it in your house maybe, Simple Green. 10-to-1 Simple Green, really works good, in case you want to clean your multi-layer insulation. That's a kind of before and after of cleaning each one of those cells on what they call the orthogrid grid. That's what it looked like when we got it. And through a process of chemicals and cleaning, we eventually got it back to its original state. And each of those blankets got cleaned and reinstalled. Now, what do you do with miles of cables? Well, initially we took it off and put them on these long tables and scrubbed them with toothbrushes, and we ran the numbers that if we do this, we won't finish for years. And someone said, how about we take it out back and pressure wash it?
Yeah.
And we did. Now, you never did. I'm an electrical engineer. This just rubs me so wrong. But they were right. For knocking off the chunks of the dirt and the grime, and low pressure, pressure wash cleaned it up pretty nice. And that's what we ended up doing. This is some more work. Now we start to get into avionics. This is real electronics. These are the actual electronic boxes that were mounted on there. And we restored those back to pristine condition. We had saved those earlier. And one thing I'll say about documentation, lifeblood. We would not have been able to do this without having the original drawings available. And this is the lead archivist at the Marshall Space Flight Center and made available to us all these original drawings. Electronically, we blew them up to E-size drawings. Little segue, and it's a human interest story. When we brought her out here and showed her what we were doing and that, she kind of got teary-eyed. I said, are you okay? She goes, you need to understand as an archivist, for decades we get this stuff in. It's rare it goes out. And we never see where it goes out and the fruits of our labor is seen. That we see that you took what we saved decades ago and are making something good of it from that. And as an archivist, that's a very positive feedback loop. We moved the cruciform one day, all wrapped up here, from where we were working at the Space Center up there into their main exhibit hall. And it was initially positioned right in the center, It's stripped now, nothing's on there other than the clean cruciform. And then we started phase two. Let's start getting the telescopes sent in. So the first one that came in was the Whoopi telescope from Wisconsin. It wasn't tied up at the Smithsonian, so that was the easiest. That was shipped down to us. There it is coming in on a delivery truck. If you haven't been up to the U.S. Space and Rocket Center, I encourage you to do so. They don't have one, they have two Saturn V's, one in the vertical, only place on the planet, and then another one in the vertical in the Davidson facility. A couple of our volunteers, and that's Whoopi shipping container. And then the installation of that. The original lifting fixture, I should say something. Our chief engineer for this project was the chief engineer for the Astro back in the 90s. So he had all of the documentation and the integration procedures and the nuts and bolts that was in his head. And so it's kind of nice being able to dust off your old procedures and use it again. The optical sensor package, that thing with, I mentioned star trackers. These are the star trackers. One last fun story about this. This piece of metal is called Invar metal. Invar doesn't change with temperature, kind of cancels each other out. This was custom made, weighs about 350 pounds. There's probably 3 people on the planet who know what that looks like. I didn't know it, and I worked on both missions because it's normally buried underneath this blanket material. One of our members happened to be in Billy Bob's back 40 somewhere outside of Huntsville, and this person had bought it for scrap metal from some auction, and Byron, my buddy, was out there for some other reason. He's one of those 3 people who look down and go, that's the optical sensor package Invar bracket. He goes, what do you do to that? Oh, I just bought it from, Marshall for scrap metal, and it's too damn heavy. And he goes, I like that. He goes, so if you can load it on the back of your pickup, you can have it. So that's how we ended up with that. And this is the lifting of the OSP. And there is a picture of the payload as it largely sits today. One final picture at the museum. We have partnerships. NASA Hunch is a high school program, and they fabricate parts for us that we're missing. We're missing a bracket. We hand them the drawings, and a chunk of stainless, and they machine it. University of Florida folks here. Yay! We thank you. University of Florida Mechanical Engineers, MEC2 and MEC3, designed us a display stand for pan and tilt that we're going to fabricate. That's the Hunch pitch. That's the UF. Here's an example of us. We were up at UF. Even we're involved with that. You might even recognize some faces here. That's one of the design teams. And we were telling them
What year?
just this last year. MEC2 and MEC3. I should remember who the professors were, I can't remember. Here's their designs, an example. We told them, how do you mount this telescope observatory on a gimbal system so when the public comes in, they can see it tilted and turning? And they came up with some brilliant examples. Marshall Space Flight Center gave us some 3D CAD modeling that allowed us to do some more engineering work that was required. And I mentioned education and outreach. Again, the engineer and me said, let's put it together, we'll be done. But no, I had no idea, and it's grown into a labor of love. In fact, this whole anniversary reunion that we did up there, 2 days of Astro Days, was for the public and for the people who worked it. We had thousands of people from the public who participated, and over 100 people from our kind of reunion that got involved. We love this. Anytime we're up there working, this is one of our engineers, actually scientists. It draws a crowd. They put a smock on and they start telling their story. So where are we going from here? We have 2 more telescopes, the Hut and UIT telescopes, to get those down from the Smithsonian. We'll continue our education outreach. We thank our partners. I'll get by the plug because I want to get through this. This is how the exhibit looks today. It's really cool what Huntsville has done for us. So this is the observatory. That's the Whoopi telescope right here. That's that optical sensor package I mentioned with the 3 tubes there. that's sitting on that whole structure, which is called the cruciform, that orthogrid structure with the blankets. You see the orbiter tail? That's actually Astra 1, the graphic blown up to scale. So when you stand in front of the exhibit, it's like you were an astronaut looking toward the tail of the orbiter. That's what you would see. Up on the right here is a 20 by 22 foot screen where we have a live video of the actual telescopes in operation. So you can see the real thing, see the real flight hardware, and then the scale on what that would be like to be an astronaut. And all of these glass displays here is signage for other components from that mission. It's a really nice display. I have to kind of brag it up. It's not great, just from our team's perspective, is the U.S. Space and Rocket Center really stepped up for us. It's world class. If you're ever in Huntsville, I would encourage you to swing by there. And this is a team picture from just 48 hours ago. And that's part of the team. But it's a labor of love. If you haven't kind of picked up on it, I go back. It's a 50-year some story. We hope it lasts another 50 years because now it'll become part of our National Archive. When we're complete with it, the intent is that all goes up to Rupert Hazy facility and part of our space heritage. So that's my talk of Astro and the Astro Restoration.
Any questions for Scott? Is that Mike Haddad?
Yes, it is. Yes, Mikey. He's our chief engineer. He's our chief engineer for this
Yeah, I used to work with him on Space Station.
And Mike, I should mention, Mike was supposed to be here. The reason he isn't, he wanted to be here. I saved him 1,400 miles of driving. He was in Huntsville with me. We both lived here. He was gonna come down, do this presentation, then turn around, he has to go back up to Indiana. And I said, I'll take care of this. You just drive north to Indiana.
I haven't seen him in 20 years.
I'll give him your name. Thank you. When we meet after. Yes.
Do you have official curriculum developed for, like, to share out with teachers?
No, absolutely. Our lead STEM education outreach contact I can give you,
Great.
and then we have scientists who have developed school program curriculums associated with Astra. So the answer is yes, and they're continuing to evolve. But that's, if you're in education,
Yeah.
we would
Very
love to talk to you.
Great. We'll chat with you after.
Okay. Anyone else? Yes, Jamie.
Who did you work with at the Rocket Center? Was that Ed Stewart?
Yeah, yes, Ed's a great guy. Apparently you know him because he lived in Florida, Brevard
Trying
County.
to recruit him, but.
You did, and then they recruited him back.
Stolen away.
Ed's been great to work with.
And he stole his wife away from our space coast up.
Okay, well,
Yeah.
then you know the history there.
That's awesome.
In fact, Ed helped us with those displays. And I don't know if you met his kind of exhibits manager, Hugh Ha is his name. The two of them came up with the ideas for the graphics in the back, the display cases. We had all the flight hardware. So we provide the goodies, and then they said, okay, here's what we're thinking. And then we had help with Teledyne Brown do all the signage. You know, we give them this much words, and they cut it down to this. You know, so, but in the right way. So the partnership's a great partnership. Absolutely. Ed is their chief curator. And in fact, Ed is joined at my hip working in negotiations with UIT and HUT. There's a little bit of a punchline there. The original, I mentioned the curator, Valerie Neal, she retired, handed the baton to David DeVorkin. David DeVorkin, we worked together with, all was good. He retired. Went to a third curator. Things were good. She moved into a new position. We got a fourth one, and then the ball got dropped. So HUT and UIT are sitting in wooden crates in the Raiders of the Lost Ark warehouse somewhere in the Beltway. And we're trying to negotiate them per the agreement, but we run into the institutional bottleneck. And we're working it, and Ed's helping us with that. So,
Yeah, it's awesome. Scott, how much did the Astro programs cost? Is there like an estimate for what the
full cost of the original programs,
Yeah.
I would only be guessing.
Yeah.
I would only be guessing because although Space Lab was a gift, yeah, in one shuttle mission, what was the shuttle flight, back in the 90s?
Well, the average is
$1
1.3 billion, right?
Yeah, so you take that, you add the science, and then, I would only be speculating. That's what made it hard when they retired this stuff, is to see this artwork.
Shocking.
Disposition.
Yeah, when, who made those decisions just to sell this?
Well, they learned from it. I'll say something. Our center director at the time saw that we were going out and doing this, and I would go meet with him and appeal that Flight Hardware should never go immediately out to Ransom Road and be sold for scrap. It should go through 20 layers, starting with this, museums and institutions and academia. And they accelerated. And the story I got, you're not gonna like this, I didn't like it, is at the end of the Space Lab program, actually, the Space Lab ended prematurely. I can say it now, enough time has passed. Dan Golden, who was our center director, our NASA administrator at the time, felt that the Space Lab program was, how do I say this? It was so fulfilling the space science community with meeting their needs that the space science community was not getting engaged with the future being space station. He said, that's our future. Quit doing these Space Lab missions, stations, the future. That's true, but the future hadn't arrived.
Yeah.
They'll hop on board as soon as you have a platform. But Dan Gold said, I'm gonna stop the program, but there was a 10-year gap. And that's water under the bridge. So here you're, and I'll draw an analogy. When Cortez landed on the new land, he burned the ships.
Yes.
Remember, he committed the troops to the new land. Dan Golden said, terminate Space Lab, and I don't want to see it again. Hence, it abbreviated past all those normal paths, right? And it went straight to the junkyard. The only things the Smithsonian grabbed was one U.S. laboratory module, that pointing system, a couple of pallets, and one other device that I didn't mention. There was a little, I'm sorry, not a million stories, but this one's a good one. The module was going to go up empty. Empty. Who wants an empty can, right? And so we went in on a weekend, about 7, 8 of us. We took a bunch of stuff that we had collected from the junk, off the junkyard, brought it and put it back into the Space Lab and filled it up so it was full of cool flight stuff. It arrives at the Smithsonian, and Valerie Neal gets it, looks in there and goes, we're supposed to get an empty one. This is great, but it's not the last mission. And the gears were turning like, what Space Lab mission is it? So at that 10-year reunion last year, 10 years ago, I told her this story. She goes, that explains it. I said, well, you're welcome very much. She knew we were the ones that stuck that forward. But had we not done that, it would have been an empty can. So there's 1,000 stories that people in museums, where do you get your hardware from? It's people who are passionate and want to preserve things. Right? So thank you for your time.
That was one more
Happy to
question.
hang out. Oh, one last question?
Just a quick question. When Dan Golden said that, was there any talk or discussion of possibly making its own satellite, its own independent, like Hubble telescope?
By then, Hubble had been flown. James Webb was in development. So from an astronomical perspective, the evolution was good. The preservation of this had nothing to do with science at this point. In fact, it was dated technology, but it was to preserve it. That's the key. Yeah, final punchline. When complete, this will be the single largest space-flown science observatory on the planet for the public to see. Let that sink in. The single largest space science That's for saving, right? You can't see Hubble, you can't see Webb, you can't see EXAF, you can't see Grove, all the great observatories are gone, but Astro that is up in Huntsville right now. So, thank you for your time.
Scott, thank you so much. Thank you for joining us for this great session today. I know Jay had to leave, so we thank Jay Honeycutt and Jamie for a great presentation.